So what we do then is we move on to what's called a surface mount component, and the surface mount resistor will typically look like this. So you'll have the resistor bit in the middle and then two pads either side of that resistor which takes the solder. Now the great thing about this is when you have a PCB, a machine can come and pick these up, because typically they will come on strings full of lots and lots of resistors. I'll show you this in more detail in a minute. So that could be fed through a pick and place machine. A robot can pick it up, stick it exactly at the right place on your board, say here. Yeah, and you've got some solder paste waiting for it. And then when it gets reflowed through an SMT oven, the temperature, the profile of the oven will melt that solder paste, and it will flow around the metal pads on the resistor and solder it down for you. No person involved, nice and easy, very quick, very cost effective. So that leads to the next thing. Of course, we know the power that we want to dissipate, for example, through this resistor. So let's say it's a standard 8-watt resistor, really tiny one. We need to decide then what size of that package we're going to use, because you'll find as technology has moved on, the components have got smaller and smaller and smaller. The end results, like things like mobile phones and watches and smart rings and everything, have forced these components to become smaller and smaller and smaller. So we typically have about 10 to 15 choices of the size of this resistor alone. And what I mean by that is you'll have a resistor that looks like this, and then another one exactly the same wattage but smaller, and it will keep going down, and keep going down. And it's represented by a code, a size code. In the case of resistors and capacitors and most inductors as well, and there are exceptions to this, is we'll have something like 1210, yeah, 06, 03, 04, 02, 02, 01. And what that represents is the size. The 12-bit is the size here, and the 10-bit the size here. Yeah? So I have got some examples here to give you an idea, which we can pass around. If we just take one of these. There we go. You can get these out. Right. Let me just have a look at these and pass them around. Okay, what's interesting here, these are called sample books. So as a developer, you can buy a book like this, and it has every value of resistor that you're likely to need in the size that you specify. Yeah, really handy to make designs with. But it gives you an idea. What I've given you there is 0603, so we've got the 6-bit represents here and the 3-bit represents here. We've got an 0402 and an 0201. Now, after 20 years of doing this, with a microscope, I can happily work with 0402s, yeah? But the 02s, 01s, remarkably small. I've been in a case before where I've had my tweezers and I've been trying to put one down, and I'm trying to solder it, I've got a microscope and everything, it's not soldering, I'm not understanding what's going on, and I find out actually the resistor's still on the table, and I picked up a piece of dirt and I'm trying to solder the dirt. Because it's that small, it's just practically, with your human hands, undoable. So a machine, no problem. So really what would happen in that case is you would design the board that's bigger, you would use bigger components, and then when you're at the final stages, everything's working, it's been characterized, you push the size down to 02s, 01s and let the machine do it. Okay? Unless you're really, really, really good, or you need to just tune the circuit or something where you may be able to spend the time to do it. So that covers the resistor footprints and capacitor footprints, and then we move on to chips. And chips work exactly the same way. You're going to have a dip. If we can see a dip chip, I think there is one in that last, do you think you could grab me one of those? In that last box there. So a dip chip would be a through-hole component, So it looked like this, yeah, on the side view. Here's a front view, and you'd have lots of legs. And these legs, if it, for example, is a dip 8, it means that it would have 8 legs altogether.
On the visualizer.
Here we have a dip 16. You can see there, we've got 1, 2, 3, 4, 5, 6, 7. So this is a dip 14, so it's got 7 legs on each side, which means if you use this component, you'll have to drill 14 holes at the correct distance. The dip is a standard distance, so whether it's a dip 4, dip 8, dip 16, whatever, the width will be a standard of 2 or 3 varieties.